Hey everyone, this is the team The Cool Beans at MakeOHI 2023. I'm Brett Schaefer, a second year CSE major, and the rest of the team consists of Sawyer Ramsey, second year CSE major, Garrett Narone, second year ISE major, and Josh Wolf, second year ECE major. I'm going to pass it off to Garrett and Sawyer to talk about our project this year.
At MakeOHI 2023, our project is a demonstration of our goal to bring more energy and cost-effective heating and cooling to homes. We built a mock house that contains two separate rooms with features to maximize our goal. It contains two heating pads at the bottom of each room, simulating radiant floor heating, a tubing system with fans and ice water to simulate chilled water air conditioning, an automated window system, a through-wall ventilation fan, and a rotary sensor to identify the wind direction. All of these features allow complete control of the temperature of the environment in the best way possible. Want to cool down one room? The system will choose the best way to do it as cheap and efficiently as possible. For example, if outside is colder and the other room is hotter, it will open the window and shut the fan. Want to warm up only one room? Then the system will turn on the heat in only the desired room if the other room is colder. If a room needs to be cooled and the outside temperature is cold with a cross breeze, the system will open the window to create an effective draft. Instead of making each of these decisions ourselves, our goal is to have the program decide to do the best possible solution based on the desired temperature requested by the client. However, in just 24 hours, this is a little ambitious, so we have created the functionality of each aspect, but it still requires manual input. The temperature display is shown using a simple Python GUI with each situation to showcase the functionalities and how they work. Looking at existing smart AC systems, they estimate saving users between 10 to 25% on costs. With our hyper-efficient project using AC and heating as minimally as possible, we are estimating saving our users 20 to 30% on total costs. How does all of this work? All of the sensors used, temperature, photoresistors, and a rotary encoder, are read through the Arduino using its analog inputs. Once read, we send the information over to the Raspberry Pi using a serial connection. Based on the given information and picked scenario, we control the fans, servos, and heating pads that are all operated using the Raspberry Pi. The main program allows customized use of our program scenarios with the hardware to simulate our project inside the mock house.
The included features of the mock house is a fan that allows air movement between the two rooms, two controllable windows, heating pads in the base of the floorboards, a flap that allows isolation of the two rooms from one another, and two AC units on the outside of the mock house. In this clip, we are demonstrating a situation where you'd want to cool your house down while it's cold outside at night, for instance. Here, we are opening both windows and turning on the fan to get a draft blowing throughout your house so you do not need to use air conditioning. In this scenario, room 1 and room 2 are much hotter than the outside of the house. So we close off and isolate room 1 from room 2 and then exhaust all the hot air out of room 1 to cool down where we are currently at. This clip demonstrates a simple use case of the program. The program automatically opens up both windows on a nice morning to let in that nice cool air. The next steps we would like to take with this project are to develop an interface for ease of use. We would also like to integrate with Home Assistant, which is an open source home automation program. A final thing we would like to do is create presets per person and a way to identify each person in a given room. This way we could dynamically adjust the room for the people inside the room.